Hey there, how's it going? Thanks for joining me today. Whether you're relaxing at home, on your commute, or winding down for the evening, I'm really glad you're here. You know, sometimes the most extraordinary moments in human history happen when nobody's really paying attention. July 1st, 2025 was supposed to be just another quiet night at the Asteroid Terrestrial Impact Last Alert System telescope, perched high in the Chilean mountains. The kind of night where computers do most of the work, scanning the heavens while astronomers catch up on paperwork or grab another cup of coffee. But that night changed everything. Before we continue this journey, tell us where you're tuning in from, and if this story resonates with you, make sure you're subscribed because tomorrow I've saved something extraordinary for you. Picture this massive telescope complex sitting at over 2,000 meters above sea level in the Atacama Desert. It's one of the clearest, driest places on Earth, perfect for watching the sky. The Atlas system isn't looking for pretty nebulae or distant galaxies. No, it's got one job: find anything that might be headed our way. Asteroids, comets, space rocks that could pose a threat to Earth. It's essentially our planet's early warning system, and it works by taking pictures of the entire sky, night after night, then comparing those images to spot anything that moves. Now, here's where it gets interesting. The computers that run Atlas are incredibly smart. They can process thousands of images, compare them automatically, and flag anything unusual. But on this particular night, something made those algorithms pause. Something was moving through space at a speed that didn't make sense. Dr. Sarah Chen was the night shift supervisor that evening. She's been studying space for over 20 years, seen plenty of asteroids and comets in her time, but when the alert came through her computer terminal, she had to look twice. The object was racing through space at 210,000 kilometers per hour. That's fast, really fast. But what made her heart skip a beat wasn't just the speed, it was the direction. You see, when objects belong to our solar system, they follow predictable patterns. They orbit the sun in ellipses, and we can trace those paths backward and forward in time. But this object, the trajectory calculations were showing something called a hyperbolic orbit, and that's the mathematical signature of something that doesn't belong here, something from outside our solar system. Think about that for a second. An object that has traveled for millions, possibly billions of years from another star system, crossing the vast emptiness between the stars, had just announced its arrival in our cosmic neighborhood. Within hours, Dr. Chen had called in confirmation observations from 3 separate telescopes. You don't take chances with something this significant. Each telescope pointed at the same patch of sky, each one confirming what the computers were telling them. Humanity was receiving its 3rd ever visitor from beyond our solar system. Now, if you've been following space news over the past few years, you might remember the first 2. There was Oumuamua back in 2017, this bizarre, cigar-shaped object that tumbled through our solar system and left astronomers scratching their heads. It was unlike anything we'd ever seen, smooth and elongated, almost like a giant space cucumber. Then in 2019 came 2I Borisov, which was much more conventional, clearly a comet with a nice normal tail, just happening to come from another star system. But this new arrival, this was different. And as the data started coming in, it became clear just how different it really was. First, there was the size. Early estimates suggested this thing could be 15 kilometers wide. To put that in perspective, that's about the size of a small city. We're talking about an object weighing over 33 billion tons. That's roughly equivalent to 40,000 Empire State Buildings, all compressed into a single cosmic wanderer. But here's what really made Dr. Chen and her colleagues stop everything they were doing. This visitor was massive compared to the previous interstellar objects. Oumuamua was maybe 400 meters long, Zhou Yusir. Impressive, But this new object appeared to be potentially 100,000 times more massive, and it was moving faster than both of its predecessors. The automated detection algorithms had stumbled upon something that would transform what started as a routine night of sky surveying into the beginning of the most controversial astronomical event of the 21st century. Because as more observations poured in over the following days and weeks, this cosmic visitor would begin revealing secrets that challenged everything scientists thought they knew about what's natural and what might be something else entirely. You know what strikes me most about this moment? It's how quickly the ordinary can become extraordinary. Dr. Chen went to work that night expecting to catalogue a few asteroids, maybe spot a known comet making its regular rounds. Instead, she became the first human being to witness the arrival of an interstellar visitor that would captivate the entire world and spark debates that are still raging today. The discovery was logged officially at 3:47 a.m. Chilean time. Within 12 hours, observatories around the globe were tracking the object. Within 24 hours, it had a designation 3IATLAS, the 3I marking it as the third confirmed interstellar object in human history, and Atlas honoring the system that found it. But naming it was the easy part. Understanding what they'd found, that was going to be a whole different challenge. As word spread through the astronomical community, something became clear very quickly. This wasn't going to be like studying a normal comet or asteroid. Those objects have been part of our solar system for over 4 billion years. We understand how they formed, what they're made of, how they behave. But 3IATLAS? This was a messenger from an alien star system, carrying secrets about worlds we've never seen and processes we've never witnessed. The first detailed observations came from the Hubble Space Telescope, which turned its incredible vision toward the visitor. What Hubble saw was both beautiful and puzzling. A nucleus potentially measuring 5.6 kilometers across, wrapped in what astronomers described as a teardrop-shaped cocoon of dust and gas. As 3IATLAS drew closer to our Sun, solar heat was causing materials on its surface to sublimate, 2p9, turning from solid directly into gas, creating this glowing envelope around the solid core. But even these early observations hinted at mysteries to come. The way the dust and gas behaved wasn't quite what scientists expected from a normal comet. There were subtle differences in the patterns, slight variations in the way material was being released. Nothing dramatic enough to set off alarm bells, but enough to make experienced astronomers take note. Dr. Chen, reflecting on that discovery night months later, would say that she knew immediately they were witnessing something special, not just because it was from another star system, that alone would have been remarkable enough, but because of the sheer presence this object commanded. Its size, its speed, its trajectory, all suggested this was no ordinary chunk of space, ice, and rock that had wandered into our neighborhood by accident. And as we'll discover, those early intuitions would prove to be more significant than anyone could have imagined, because 3IATLAS was just getting started revealing its secrets. The anomalies that would soon emerge from careful study would challenge our understanding of what's possible in the natural universe and force scientists to ask questions they never thought they'd have to consider seriously. The night of July 1st, 2025, marked the beginning of a cosmic detective story that would unfold over the following months, involving telescopes on multiple continents, spacecraft throughout our solar system, and ultimately sparking a global conversation about humanity's place in a universe that might not be as empty as we once believed. From that quiet night in the Chilean mountains, with Dr. Chen staring at her computer screen and realizing she was looking at something unprecedented, to the worldwide phenomenon that 3IATLAS would become, it all started with algorithms doing their job just a little too well and finding something that would make the entire world look up at the stars and wonder, what if we're not alone? But we're getting ahead of ourselves. Because before 3I80 LAS could become the center of global conspiracy theories and scientific debates, it had to reveal just how strange it really was. And those revelations? They were about to turn everything astronomers thought they knew about interstellar visitors completely upside down. Next time, we'll dive into the observations that made even seasoned scientists question their instruments, and discover why this cosmic visitor decided to rewrite the rules of physics as we know them. Welcome back. I hope you're as fascinated by this story as I am, because what we discovered about 3I80LAS in those first few weeks of observation, well, let's just say it challenged everything we thought we knew about how the universe works. As summer 2025 rolled on, astronomers around the world trained their most powerful instruments on our mysterious visitor, and with each new observation, 3I80LAS revealed behaviors that made even the most experienced scientists do double takes and check their equipment. Because this cosmic wanderer wasn't just unusual, it was actively defying the fundamental rules that govern how comets are supposed to behave. Let me paint you a picture of what we normally see when a comet approaches the Sun. It's actually quite beautiful and predictable. As the comet gets closer, solar radiation heats up the icy materials on its surface. These materials sublimate. That's when they skip the liquid phase and go straight from solid to gas. This creates a glowing cloud around the nucleus, called a coma, and the solar wind, those charged particles streaming out from the sun, pushes this material away, creating that magnificent tail we've all seen in photographs. Every single comet humanity has ever observed follows this basic pattern. The tail always points away from the sun, like cosmic hair blowing in a stellar breeze. It's one of those fundamental rules of physics that you can count on. Until 3I80LAS decided to rewrite the rulebook. Dr. Maria Rodriguez at the Very Large Telescope in Chile was running spectroscopic observations, basically analyzing the light coming from 3I80LAS to figure out what it was made of. Spectroscopy is like having cosmic DNA analysis. Different elements and compounds absorb and emit light at specific wavelengths, creating unique signatures that tell us exactly what we're looking at. But on the night of August 15th, Dr. Rodriguez saw something in her data that made her question whether her instruments were malfunctioning. The spectroscopic readings showed a distinct jet of material pointing directly toward the Sun, not away from it. Toward it. Think about that for a moment. Imagine you're standing next to a powerful fan that's blowing air away from you. You'd expect anything loose, your hair, your clothes, to blow in the direction of the airflow, right? You wouldn't expect it to blow back toward the fan, but that's essentially what 3I80LAS was doing. It had developed what astronomers started calling an anti-tail, material flowing in the opposite direction of what physics said should be possible. Dr. Rodriguez ran the analysis 3 more times that night, thinking there had to be an error, but every time the results were the same. 3I80LAS was exhibiting behavior that shouldn't exist according to conventional physics. Now, here's where things get even stranger. The trajectory itself was raising eyebrows throughout the astronomical community. You see, when objects wander through the galaxy, they should arrive from random directions. Space is big, really big, and the chances of an interstellar visitor arriving along any particular path should be roughly equal from all directions. But 3I80LAS hadn't arrived from a random direction. Instead, it aligned itself within 5 degrees of what we call the ecliptic plane. That's the flat disk where all our planets orbit around the Sun. Imagine throwing a dart at a spherical dartboard from across a football field and hitting within 5 degrees of the bullseye. The odds of this happening by pure chance? Approximately 1 in 10,000. Dr. James Mitchell at the Harvard-Smithsonian Center for Astrophysics spent weeks running trajectory simulations, trying to figure out how this alignment could have occurred naturally. He told colleagues it was like watching a cosmic billiard ball that seemed to know exactly where it was going. But the really mind-bending revelation was still to come. As more telescopes joined the observation campaign and better data started flowing in, astronomers began to grasp the true scale of what they were dealing with. The Hubble Space Telescope had been tracking 3I-ATLAS since early August, using its incredible resolution to study the nucleus and surrounding coma. When the size calculations came back, they stunned the entire astronomical community. This object appeared to be between 1,000 and 100,000 times more massive than the previous interstellar visitors we'd encountered. Let me help you visualize this difference. Oumuamua, our first confirmed interstellar visitor, was maybe 400 meters long, about the length of 4 football fields. Respectable, but not enormous. Tuai-Borisov, the second visitor, was even smaller, but 3I-ATLAS, the Hubble observations suggested a nucleus potentially measuring 5.6 kilometers across. That's like comparing a golf ball to a basketball, then jumping up to a small moon. And here's what really blew everyone's minds. Despite being so much more massive than its predecessors, 3I-ATLAS was actually moving faster than both of them. That's not how physics typically works. Larger objects in space usually move more slowly, especially when they're traveling between star systems. The energy required to accelerate something that massive to such high speeds is almost incomprehensible. Dr. Susan Walsh at the European Southern Observatory described it perfectly when she told her team, "It's like watching a freight train outrun a sports car. The math just doesn't add up." But the visual spectacle was just as remarkable as the numbers. As 3I-ATLAS continued its approach toward the inner solar system, it began developing what observers described as a teardrop-shaped cocoon of dust and gas. This wasn't the typical spherical coma that most comets develop. Instead, it looked almost intentional, streamlined, like something designed to move efficiently through space. The color was striking too. As carbon dioxide sublimated from the surface, 3I-ATLAS took on an eerie green luminescence that made it stand out dramatically against the black backdrop of space. Observers using smaller telescopes reported that it almost seemed to pulse with this green glow, though that was likely an optical illusion caused by the way our eyes perceive light at the edge of visibility. Dr. Rodriguez, who had first spotted the anti-tail phenomenon, continued her spectroscopic studies throughout August and September. What she found only deepened the mystery. The chemical signature of 3I-ATLAS didn't quite match what astronomers expected from a typical comet. Normal comets are basically dirty snowballs left over from the formation of their parent star system. They're made of water ice, frozen carbon dioxide, methane, ammonia, and various rocky materials. The spectroscopic signature should be fairly predictable. But 3I-ATLAS was showing unusual concentrations of certain elements and unexpected ratios of others. "It's like analyzing a recipe you've made 1,000 times, Dr. Rodriguez explained to a colleague, "and discovering someone has added ingredients you've never seen before." The nickel content was particularly puzzling. While nickel isn't unheard of in comets, 3I-ATLAS seemed to have much higher concentrations than normal, and there were trace signatures of elements that took weeks to identify properly. As September rolled into October, observatories worldwide were dedicating unprecedented amounts of telescope time to studying this cosmic visitor. The European Southern Observatory, the Keck telescopes in Hawaii, the Very Large Telescope in Chile, all of them were contributing data to what had become the most intensive study of an interstellar object in human history. But every new observation seemed to raise more questions than it answered. The rotation rate was odd, faster than expected for an object of that size. The way material was being expelled from the nucleus didn't follow standard models of comet behavior. Even the trajectory showed subtle variations that couldn't be fully explained by gravitational influences alone. Dr. Mitchell at Harvard started compiling what he called the anomaly list, a growing catalogue of behaviors that didn't fit conventional models. By early October, that list had grown to 8 major discrepancies between 3I ATLAS and every other comet or asteroid ever studied. And here's what made all of this even more intriguing. 3I ATLAS was getting brighter. As it approached the Sun, but not in the way astronomers expected. The brightness curve, how an object's apparent magnitude changes as it gets closer to our star, wasn't following the standard pattern. It was almost as if internal processes were contributing to the brightness, not just reflected sunlight and sublimating ice. Some observers reported seeing what looked like structured patterns in the coma, 19 regions, of higher and lower density that seemed organized rather than random. When these reports first surfaced, most astronomers dismissed them as observational artifacts or wishful thinking. But as more telescopes confirmed similar patterns, the scientific community had to admit they were seeing something genuinely unusual. The public hadn't really caught wind of just how strange 3I ATLAS was becoming. The astronomical community was still in data-gathering mode, trying to understand what they were observing before making any bold pronouncements. But behind the scenes, in observatories and university departments around the world, conversations were happening that hadn't taken place since the discovery of Oumuamua. Dr. Walsh summed up the mood perfectly in a private email to colleagues. "We've been studying comets for centuries. We understand how they work, what they're made of, how they behave. But this thing, it's like someone handed us a Ferrari and told us it runs on water. Everything we think we know says it shouldn't be possible, but here it is, right in front of us." As October progressed and 3I ATLAS continued its journey toward the inner solar system, astronomers were preparing for the most critical phase of observation. The object would soon make its closest approach to the Sun, the point where comet activity typically reaches its peak. If 3I ATLAS was going to reveal its deepest secrets, this would be the moment. But nobody, not Dr. Rodriguez with her spectroscopic expertise, not Dr. Mitchell with his trajectory calculations, not Dr. Walsh with her decades of comet observation experience, nobody was prepared for what would happen next. Because just as 3I ATLAS was about to enter its most active phase, just when all the world's telescopes were positioned to study it most closely, the cosmic visitor was about to pull off the ultimate disappearing act. And when a Harvard professor suggested that this disappearance might not be accidental, the entire world would finally learn just how extraordinary 3I ATLAS really was. All right, here's where our story takes a turn that nobody saw coming. Because just when astronomers were scratching their heads over all these anomalies we talked about last time, one of the most respected voices in astrophysics decided to ask the question that would change everything. What if 3I ATLAS isn't natural at all? Dr. Avi Loeb had already made quite a name for himself in the astronomical community. As the former chair of Harvard's astronomy department, he'd built a stellar reputation studying black holes, the first stars in the universe, and the search for extraterrestrial life. But he'd also earned a reputation as someone willing to think outside the box, sometimes way outside the box. You might remember Dr. Loeb from his controversial suggestions about Oumuamua back in 2017. While most astronomers concluded that our first interstellar visitor was just a weird-shaped asteroid, Loeb proposed something that made headlines around the world. What if it was actually alien technology? A light sail, perhaps, designed by an extraterrestrial civilization and sent drifting through the galaxy. The scientific establishment wasn't exactly thrilled with that idea. Colleagues criticized him for speculation without sufficient evidence. Some accused him of seeking publicity rather than practicing rigorous science. But Loeb stood by his reasoning. Extraordinary objects deserve extraordinary consideration, and we shouldn't dismiss possibilities just because they make us uncomfortable. So, when 3IATLAS appeared with its constellation of anomalies, AS, the antitail, the perfect trajectory alignment, the impossible size-to-speed ratio, Dr. Loeb saw something that other astronomers were trying very hard not to think about. He saw an opportunity to test his most radical ideas about what might be traveling between the stars. The paper that would change everything was published on July 16, 2025, just 15 days after 3IATLAS was first detected. Loeb and his colleagues at the Initiative for Interstellar Studies released a preprint, that's a scientific paper that hasn't been peer-reviewed yet, with a title that was like dropping a bomb into the astronomy community. Is the interstellar object 3I a TLAS alien technology? Now, I want you to understand how unprecedented this was. Respected scientists at elite institutions don't typically publish papers suggesting that comets might be spacecraft. The very fact that Harvard-affiliated researchers were willing to put their names on such a hypothesis sent shockwaves through both scientific and social media communities. But here's the thing. Loeb's hypothesis wasn't just wild speculation. It was based on a sophisticated understanding of orbital mechanics and a spaceflight technique that's absolutely real and well established. The core of Loeb's theory centered on something called the Oberth effect. This is a genuine principle that spacecraft engineers use all the time. Here's how it works. When a spacecraft wants to change its velocity as efficiently as possible, the best time to fire its engines is at the point of closest approach to a massive body like a star or planet. At that moment, the spacecraft is moving at its highest speed, and any additional acceleration gets amplified by the gravitational environment. It's like the difference between pushing a car that's already rolling versus pushing one that's sitting still. The energy you put in has much more effect when the object is already in motion. Now, here's where it gets interesting for 3IATLAS. The object's trajectory would take it on a perfect path for executing an Oberth maneuver. It would reach its closest approach to the Sun, the point where such a maneuver would be most effective, on October 30th, 2025. And here's the kicker. At that exact moment, 3IATLAS would be positioned directly behind the Sun from Earth's perspective, completely hidden from all of our telescopes. Think about that timing for a moment. If you were an alien spacecraft wanting to change course without being observed by the inhabitants of the third planet, you couldn't ask for a more perfect setup. Maximum efficiency for course corrections combined with complete concealment from prying eyes. Loeb's mathematical analysis was thorough and sobering. He calculated that if 3IATLAS was indeed artificial, it could use this hidden solar approach to dramatically alter its trajectory. Instead of continuing on its current path out of the solar system, it could potentially redirect itself toward Earth, arriving in our vicinity by November or December 2025. But wait, it gets even more dramatic. In interviews following the paper's release, Dr. Loeb made a statement that would be quoted around the world. If you want to take a vacation, take it before October 29th, because who knows what will happen. Now, he was being somewhat tongue-in-cheek, but the underlying mathematics was serious. Loeb assigned a 30 to 40% probability that 3IATLAS didn't have a fully natural origin. In the world of astronomy, where scientists typically hedge their bets and speak in careful probabilities, this was basically equivalent to standing up and shouting. The paper described what Loeb called a potential black swan event, a rare occurrence with massive implications. The idea was that technological objects might masquerade as natural comets, using the perfect camouflage of appearing to be ordinary space rocks, while actually being sophisticated probes capable of reconnaissance missions or deploying smaller craft during their hidden approach. Loeb laid out a scenario that read like science fiction, but was grounded in real physics. During its passage behind the Sun, 3IATLAS could theoretically conduct detailed observations of our solar system without being detected. It could deploy smaller probes that would be impossible to spot against the Sun's glare. It could even drop technology or biological materials that would eventually make their way to Earth. The timing, Loeb argued, seemed almost too convenient. The object arrives aligned with our planetary plane, exhibits unusual behavior that suggests it might not be entirely natural, then disappears behind the Sun at the exact moment when any technological civilization would want to conduct operations unobserved. The consequences, should the hypothesis turn out to be correct, the paper stated with characteristic understatement, could potentially be dire for humanity and would possibly require defensive measures to be undertaken, though these might prove futile. Now, Dr. Loeb was careful to emphasize that this was largely what he called a pedagogical exercise, a teaching tool designed to encourage rigorous observation and open-minded thinking. He repeatedly stated that the most likely outcome would be that 3IATLAS was completely natural. But here's what made his hypothesis so compelling. He wasn't just throwing out wild ideas, he was proposing specific, testable predictions. If 3IATLAS was artificial, it should behave in certain ways during its solar approach. It might not develop the increased comet activity that natural objects show when heated by the sunday. It might exhibit controlled course corrections. It might even attempt to communicate or deploy technology. The reaction was immediate and intense. Within hours of the paper's release, scientific Twitter was buzzing with responses ranging from thoughtful analysis to outright dismissal. Mainstream astronomers pointed out that extraordinary claims require extraordinary evidence, and that all observations so far were consistent with 3IATLAS being a very unusual but still natural comet. Dr. Chris Lintott from Oxford University called the alien hypothesis absolute nonsense, emphasizing that the object was clearly behaving like a comet and following gravitational laws. NASA's Planetary Defense Office issued statements reassuring the public that 3IATLAS posed no threat to Earth and was showing all the expected signs of natural comet activity. But the damage, or depending on your perspective, the spark, had been lit. Within 48 hours, the story had jumped from academic preprint servers to mainstream media. The New York Post ran a headline claiming the comet was larger than previously thought, could be alien tech. Cable news shows began featuring segments on humanity's potential first contact with extraterrestrial intelligence. And that's when things really started to get interesting. Because while the scientific community was debating the merits of Loeb's hypothesis, social media was about to take the story and run with it in directions that nobody could have predicted. Dr. Loeb himself seemed almost surprised by the explosion of interest. In later interviews, he would emphasize that his goal was to encourage more rigorous observation of 3IATLAS, not to convince people that aliens were definitely coming. He wanted astronomers to collect as much data as possible to prove him wrong, Mao right. Even if 49 out of the next 50 interstellar objects turn out to be natural, he said, the one outlier of technological origin might change the future of humanity. But the internet had heard alien spacecraft and Harvard professor, and the combination was irresistible. What started as a carefully reasoned scientific hypothesis was about to become the center of the largest viral conspiracy phenomenon of the digital age. The irony wasn't lost on Dr. Loeb. He'd spent his career studying the universe's most exotic phenomena, 19's black holes, dark matter, the cosmic dawn, IS, but it was a paper about a possible alien comet that would make him a household name and transform him from respected academic into the world's most famous advocate for taking extraterrestrial technology seriously. As October 2025 approached, and 3IAT LAS, drew closer to its mysterious rendezvous behind the sun, the world found itself in the unprecedented position of actually wondering, what if the Harvard professor was right? What if humanity was about to experience its first confirmed encounter with alien intelligence? The stage was set for the most closely watched disappearing act in human history, and as we'll discover, the way the world reacted to the possibility of alien contact revealed just as much about humanity as it did about our cosmic visitor. What happened next was like watching a match being struck in a room full of gasoline. Within 48 hours of Dr. Loeb's paper hitting the internet, social media platforms across 5 continents erupted with 3 IATLAS theories that ranged from thoughtful scientific discussion to complete fantasy. It was a masterclass in how information spreads in the digital age, and how quickly hope, fear, and imagination can overwhelm facts. The transformation started innocuously enough. On September 29th, the New York Post published an article with the headline, "Massive comet hurtling toward us is larger than previously thought. Could be alien tech," scientist says. It was a fairly standard science journalism piece, summarizing Loeb's hypothesis and including the usual caveats about the need for more evidence. But what happened next shows you just how powerful social media algorithms can be when they latch onto something that triggers strong emotional responses. The story began metastasizing across digital networks with lightning speed, and with each share, each repost, each comment, the narrative evolved and amplified in ways that would have been impossible in the pre-internet age. The first major viral moment came from an account called Lord Bebo, which shared what appeared to be quotes from physicist Michio Kaku discussing 3 IATLAS. The post included a doctored screenshot from what looked like a television interview, with Kaku supposedly saying that 3 IATLAS was approaching Earth to conduct a reconnaissance mission, possibly with hostile intent, and might be an alien probe sent to Earth. The post was accompanied by dramatic text warning about the object's unexplainable acceleration and claiming it was approaching Earth, closer than expected. Within hours, it had garnered over 290,000 views and hundreds of shares. There was just one problem. Michio Kaku had never said any of those things about 3 IATLAS. The image was from an older interview from February 2025, 80 months before 3 IATLAS was even discovered, where Kaku was discussing a completely different topic. But by the time fact-checkers caught up with the viral post, it had already spread across multiple platforms and been translated into dozens of languages. This is where the story gets really fascinating from a sociological perspective. The fake Kaku quotes didn't exist in isolation. They became the foundation for an entire ecosystem of 3 IATLAS content that took on a life of its own. In India, the story exploded across WhatsApp forwards and Hindi YouTube channels almost overnight. Content creators began linking 3 IATLAS to ancient Vedic prophecies about celestial visitors. Some videos claimed that Sanskrit texts had predicted the arrival of a divine chariot from beyond the stars in 2025. These videos were garnering hundreds of thousands of views, with comment sections filled with people sharing their own theories and experiences. The Japanese response was particularly creative. Social media users on platforms like X and Line began weaving 3 IATLAS into elaborate threads that connected the comet's trajectory to anime plotlines about alien invasions. The hashtag 3IATLAS-san started trending, treating the cosmic visitor like an anime character with its own backstory and motivations. Some users created detailed timelines, showing how the comet's arrival coincided with significant dates in Japanese pop culture, creating a blend of conspiracy theory and entertainment that was uniquely Japanese. Italian TikTok took a different approach entirely. The platform exploded with a mixture of humorous memes and genuine concern. Users created fake emergency broadcast videos warning about the approaching mothership, complete with dramatic music and government-style graphics. Some of these videos were clearly parody, but others were so well produced that viewers couldn't tell if they were real or fake. The hashtag number Atlas Arriva became a trending topic, with millions of views across thousands of videos, but it was the conspiracy ecosystem that really showed how modern misinformation networks operate. Within days of the Loeb paper's release, a complex web of interconnected theories had emerged that went far beyond anything the Harvard professor had suggested. The theories developed their own internal logic that became increasingly elaborate. Some claimed that 3I-ATLAS was just the advanced scout for a larger invasion fleet. Others suggested it was a Trojan horse comet, appearing natural from the outside but containing alien technology within. There were theories about the object being controlled by the Galactic Federation, about it preparing to deploy biological weapons, and about world governments already knowing the truth, but keeping it hidden. Military movements that had nothing to do with 3I-ATLAS were reported as evidence of secret preparations for alien contact. When NASA temporarily restricted some observational data during the Mars flyby period, APAC, a routine procedure to ensure data quality, MAC, conspiracy theorists interpreted this as proof of a government cover-up. Amateur astronomers began claiming they could detect unusual Doppler shifts in the object's radio emissions that resembled coded communications. Groups of citizen researchers started organizing online to analyze publicly available telescope data, looking for hidden patterns that professional astronomers might have missed. The remote viewing community, AD, people who claimed to be able to observe distant locations or events through psychic means, latched onto 3I-ATLAS with particular enthusiasm. Multiple remote viewers posted detailed descriptions of their psychic observations of the object, describing ancient alien technology, plans to drop microbes on Earth, and visions of cosmic civilizations using the comet as a reconnaissance probe. One particularly viral claim came from someone calling themselves NYC Crypto King, who posted, "Just remote viewed interstellar comet 3I-ATLAS. It's pulling energy from everywhere around it, glowing intensely bright as it accelerates. This thing is ancient. Tech only advanced aliens could build. Onboard, tiny microbial life. Its plans to drop on Earth during its solar approach." The post gained tens of thousands of shares and spawned countless response videos and discussion threads. What's fascinating is how these different conspiracy communities began feeding off each other. A theory that started in one country or language would get translated and adapted by communities elsewhere, often gaining new elements in the process. The Hindu YouTube channel started incorporating Japanese anime references. Italian TikTok users began sharing content from American polls of line. Conspiracy researchers. The global nature of social media created a kind of collaborative fiction that was constantly evolving. Dr. Loeb himself watched this explosion with a mixture of fascination and concern. In later interviews, he would note that while he appreciated the public interest in astronomy, the viral theories had moved far beyond anything he'd actually proposed. He repeatedly emphasized that his paper was primarily a thought experiment designed to encourage rigorous observation, but the internet had heard Harvard professor and alien spacecraft and decided to run with it. Traditional media outlets found themselves in the unusual position of having to fact-check not just the original scientific claims, but an entire mythology that had grown up around them. The phenomenon reached such proportions that space agencies felt compelled to respond. NASA issued multiple statements clarifying that 3I-ATLAS posed no threat to Earth and was showing all the expected signs of natural comet activity. The European Space Agency released detailed explanations of how comets work and why 3I-ATLAS's behavior, while unusual, was within the range of natural phenomena. But for many people caught up in the excitement, these official statements only reinforced their belief that something was being hidden. The fact that government agencies were explicitly denying the alien hypothesis was taken as evidence that the alien hypothesis might be true. This created a feedback loop that researchers who study misinformation know well. The more authorities denied the extraordinary claims, the more convinced believers became that there was a cover-up. The more evidence scientists provided for natural explanations, the more elaborate the alternative theories became. By early October 2025, 3I-ATLAS had become more than an astronomical object. It had become a cultural phenomenon. The hashtag was trending globally. News outlets were running daily updates. Talk shows were featuring debates between astronomers and UFO researchers. The visitor from another star system had become the center of the largest viral conspiracy event in the history of social media. And all of this was happening while the actual object was still approaching the most critical phase of its journey. As October progressed and 3I-ATLAS drew closer to its rendezvous behind the sun, the volume of online speculation reached a fever pitch. Some groups organized 3I-ATLAS watch parties, where people would gather to observe the comet through telescopes and share their experiences online. Others created countdown timers to October 30th, the date when the object would reach its closest approach to the Sunday. Still others began preparing for what they believed might be first contact with extraterrestrial intelligence. The global response revealed something profound about human nature in the digital age. When faced with the unknown, when presented with the possibility that we might not be alone in the universe, people didn't just passively wait for answers from scientists. They actively participated in creating meaning, constructing narratives, and sharing experiences that helped them process the implications of what might be happening. Whether 3I-ATLAS turned out to be alien technology or just a really interesting comet, the global response had already changed something fundamental about how humanity deals with cosmic mysteries. We'd entered an age where scientific discoveries don't just belong to scientists. They belong to everyone with an internet connection and an imagination. As the countdown to October 30th continued, the entire world found itself watching the skies and wondering, what would happen when 3I-ATLAS disappeared behind the sun? Would it emerge as just another comet, or would humanity's first encounter with alien intelligence unfold in the hidden shadows of our own star? The stage was set for the most closely watched disappearing act in human history. October 21st, 2025 will go down in history as one of the most nerve-wracking days in modern astronomy, because that's when 3I-ATLAS began its ultimate disappearing act, vanishing behind the sun just as the entire world was watching and wondering what might happen next. Solar conjunction, AJ, that's the technical term for when a celestial object passes directly behind the sun from Earth's perspective, AJ, is actually a fairly common occurrence in astronomy. Planets do it regularly. As they orbit, the Sunday spacecraft lose contact with Earth for weeks at a time when they pass behind our star. It's a routine part of celestial mechanics that astronomers deal with all the time. But there was nothing routine about 3I-ATLAS entering solar conjunction. Not when conspiracy theories were raging across social media. Not when a Harvard professor had suggested this might be the perfect moment for an alien spacecraft to execute hidden maneuvers. And definitely not when the entire world was watching to see what would emerge on the other side. For conspiracy theorists, the timing seemed too perfect to be coincidental. Here was an object that had already exhibited impossible behavior. The anti-tail, the perfect trajectory alignment, the massive size combined with incredible speed, and now it was about to disappear from view at the exact moment when any technological civilization would want to conduct operations unobserved. Think about it from a strategic perspective. If you were an alien probe wanting to change course, deploy smaller craft, or conduct detailed reconnaissance of a solar system, You couldn't ask for better cover than being hidden behind a star. The sun's immense brightness and electromagnetic radiation would mask any signals, hide any course corrections, and provide perfect camouflage for technological activities. Dr. Loeb's Oberth maneuver hypothesis had planted this idea in the public consciousness, and now it was about to be put to the ultimate test. During the weeks when 3I TLAS would be invisible from Earth, the object would reach perihelion, ADA, its closest approach to the Sun, on October 30th. This was the mathematically optimal moment for any spacecraft to fire its engines and achieve maximum velocity change using the Sun's gravity. But here's where the story gets really interesting from a technical perspective. While 3I TLAS would be invisible from Earth, it wouldn't be invisible to all of humanity's instruments. Mission controllers at space agencies around the world suddenly found themselves scrambling to repurpose spacecraft that were never designed for this kind of observation. The European Space Agency faced the biggest challenge. Their ExoMars Trace Gas Orbiter and Mars Express spacecraft were positioned to get the closest view of 3I ATLAS during its hidden passage. But these were orbiters designed to photograph Mars from a few hundred kilometers away, with cameras optimized for studying planetary surfaces. Now they needed to track a relatively dim object 30 million kilometers distant. Dr. Nick Thomas, the principal investigator for the CASIS camera system on the ExoMars orbiter, described the challenge perfectly. This was like trying to use a microscope to spot an airplane. The cameras simply weren't designed for this kind of long-distance observation. But the stakes were high enough that space agencies decided to try anyway. Engineers worked around the clock to reprogram the Mars orbiters, adjusting their pointing systems and observation schedules to track 3I ATLAS during its approach to the Sunday. The technical challenges were immense. Mars orbiters are typically synchronized with the planet's rotation and surface features. They follow predictable patterns designed to map geological formations and atmospheric conditions. Suddenly, asking them to track a fast-moving object against the RUFOR stellar background was like asking a security camera to follow a speeding car. Possible, but requiring completely different operational procedures. Meanwhile, NASA's Juno spacecraft, orbiting Jupiter, received its own set of urgent trajectory updates. Juno was positioned to potentially observe 3I ATLAS as it emerged from behind the Sun, when comet activity should be at its peak due to maximum solar heating. The spacecraft's instruments, designed to study Jupiter's atmosphere and magnetic field, would need to be retasked for comet observation. The European Space Agency's JUICE mission, ATTU, the Jupiter Icy Moons Explorer, also received emergency instructions to optimize its position for 3I ATLAS observation. JUICE was originally launched to study Jupiter's moons, Europa, Ganymede, and Callisto, but now it found itself drafted into the most closely watched astronomical observation campaign in history. Back on Earth, only one instrument maintained the ability to glimpse 3I ATLAS during its hidden passage, the GOES-19 weather satellite. Positioned in geostationary orbit to monitor Earth's weather patterns, GOES-19 had the unique advantage of being able to observe the Sun directly and potentially spot the comet silhouetted against our star's brilliant disk. But even GOES-19 faced limitations. The Sun's intense brightness meant that any observations would be extremely difficult and potentially dangerous to the satellite's instruments. Engineers had to develop special filtering techniques and modify observation protocols to protect the spacecraft while still attempting to track the mysterious visitor. As October 21st arrived and 3I ATLAS began to disappear behind the Sun's glare, something unprecedented happened in the history of space exploration. For the first time ever, multiple space agencies coordinated a real-time observation campaign of an object that most of the world believed might be alien technology. The coordination required split-second timing, as 3I ATLAS moved behind the Sun from Earth's perspective, it remained visible from Mars for several additional hours. Then, as it disappeared from Mars's view, Jupiter-based observers would have their chance. The handoff between different spacecraft had to be precisely timed to maintain continuous observation. Dr. Emma Richardson, mission director for the ExoMars program, later described those first few days as the most intense operational period in European space exploration history. Ground controllers were working in 12-hour shifts, monitoring data streams from multiple spacecraft, adjusting observation parameters in real time, and coordinating with NASA and other international partners. But the technical challenges were nothing compared to the psychological pressure. Every piece of data, every image, every measurement was being analyzed not just for scientific value, but for any sign of artificial behavior. If 3IATLAS was going to reveal its true nature, this would be the moment. The first images from the Mars orbiters were both encouraging and frustrating. Encouraging because they showed that the spacecraft could indeed track the distant object. Frustrating because the resolution was so limited that detailed analysis was nearly impossible. 3IATLAS appeared as little more than a fuzzy white dot moving against the background stars, but that fuzzy white dot was behaving exactly as astronomers expected a natural comet to behave. As it approached closer to the Sun, the coma, I see well, that cloud of gas and dust surrounding the nucleus, was becoming more active. The object was brightening in a pattern consistent with increased sublimation of icy materials. However, conspiracy theorists weren't satisfied with these observations. The fact that the images were low resolution was interpreted as evidence that space agencies were hiding better data. Some claimed that the fuzzy appearance was actually proof that 3IATLAS was using some kind of cloaking technology. Online discussions reached fever pitch as October 30th approached. Countdown timers appeared on websites around the world. Social media feeds filled with speculation about what might happen at the moment of perihelion. Some groups organized contact vigils, where people would meditate or attempt psychic communication with the hidden visitor. The tension was particularly intense at observatories and space agencies, where scientists found themselves in the surreal position of conducting routine comet observations while the entire world watched for signs of alien intervention. Dr. Sarah Chen, the astronomer who had first spotted 3IATLAS back in July, was working extended shifts at the Atlas Telescope facility in Chile. Even though the comet was invisible to Earth-based telescopes, she and her colleagues were analyzing every piece of data from the spacecraft observations, looking for any anomaly that might support or refute the alien hypothesis. It was the strangest period of my career, Dr. Chen would later recall. We were doing normal astronomy, tracking a comet, measuring its brightness, analyzing its composition, a Vocto, but we were also aware that half the world was convinced we might be witnessing first contact with extraterrestrial intelligence. As October 30th arrived, the moment of 3IATLAS's closest approach to the Sun, observatories worldwide held their breath. If Dr. Loeb's hypothesis was correct, this would be the moment when an alien spacecraft might execute its hidden maneuver. Course corrections, deployment of smaller probes, or changes in behavior that would reveal the object's artificial nature. The data from GOES-19 was tantalizing but inconclusive. The weather satellite detected what appeared to be increased activity around 3IATLAS at perihelion, but determining whether this was natural comet behavior or something else was impossible given the observation limitations. Jupiter-based observations from Juno were still days away if the spacecraft needed time to process and transmit the massive amounts of data it was collecting. Ground controllers would have to wait until early November to see the detailed results of humanity's most ambitious attempt to observe a potentially alien visitor. But even as the world waited for definitive answers, one thing was already becoming clear. The disappearance of 3IATLAS had revealed something profound about humanity itself. Never before had so many people around the world simultaneously focused their attention on a single cosmic event. Never before had the possibility of alien contact been taken so seriously by so many. Whether 3IATLAS turned out to be natural or artificial, the Great Disappearance had already changed us. We demonstrated our ability to coordinate global observation campaigns, to repurpose spacecraft for unexpected missions, and to unite in wonder and anticipation about our place in the universe. As November began and 3IATLAS prepared to emerge from behind the sun, the entire world held its breath. The most closely watched disappearing act in human history was about to reveal its secrets. And whatever those secrets turned out to be, humanity would never look at visitors from other star systems the same way again. The moment of truth was approaching, and with it, answers that would either confirm our cosmic loneliness or change the course of human history forever. Early November 2025 marked the moment when speculation would finally meet reality. As 3IATLAS emerged from behind the sun, a flood of data from multiple spacecraft began painting the most detailed picture ever assembled of an interstellar visitor. And what that picture revealed would either validate the greatest discovery in human history or demonstrate the power of the scientific method to distinguish between hope and truth. The first definitive results came from NASA's Juno spacecraft, positioned perfectly to observe 3IATLAS as it rounded the sun and began its journey back toward interstellar space. Juno's instruments, originally designed to study Jupiter's magnetic field and atmosphere, had been repurposed for the most important comet observation in history. Dr. Jennifer Walsh, Juno's mission scientist, was part of the team analyzing the incoming data in real time. What they found was both remarkable and, in many ways, exactly what conventional astronomy predicted. The moment we saw the first spectroscopic readings, Dr. Walsh later recalled, "We knew we were looking at something extraordinary, but extraordinary in the way that all interstellar objects are extraordinary, not in the way that alien technology would be extraordinary." The James Webb Space Telescope's near-infrared spectrograph had been tracking 3IATLAS throughout its hidden passage, and as the comet emerged from solar conjunction, Webb's incredible sensitivity began revealing the object's chemical composition in unprecedented detail. What Webb detected was a perfect match for conventional comet models. High concentrations of carbon dioxide streaming from the nucleus as solar heat triggered sublimation, water vapor escaping in exactly the patterns that physics predicted, carbon monoxide outgassing at rates consistent with the heating profile of a natural icy body approaching the sunday. These weren't surprising results. They were exactly what astronomers expected to see from a comet, even one from another star system. But in the context of the global speculation surrounding 3IATLAS, these ordinary findings carried extraordinary weight. Dr. Darrell Seligman, who had led the first comprehensive study of 3IATLAS, was analyzing data from multiple telescopes simultaneously. His team at the University of Chicago had developed sophisticated computer models of how interstellar comets should behave, and 3IATLAS was matching those models with remarkable precision. Every single observation was demonstrating classical signatures of cometary activity. Dr. Seligman explained to his colleagues, the outgassing patterns, the brightness variations, the way material was being expelled from the nucleus, even it all pointed to completely natural processes. But the most telling evidence came from trajectory analysis. If 3IATLAS had executed any kind of course correction during its passage behind the Sun, 21, the kind of Oberth maneuver that Dr. Loeb had proposed, it would show up as unexplained changes in the object's velocity or direction. Teams at NASA's Jet Propulsion Laboratory and the European Space Agency had been running continuous calculations of 3IATLAS's orbit, tracking every minute change in its position and speed. The analysis required extraordinary precision, 10 Pe, detecting velocity changes of just a few meters per second across distances of millions of kilometers. The results were unambiguous. 3IATLAS was following a purely gravitational trajectory, with no evidence of artificial acceleration or course corrections. The object was behaving exactly like a passive body, influenced only by the sun's gravity, with no signs of propulsion or controlled maneuvering. Even the mysterious anti-tail that had puzzled astronomers during the summer found a natural explanation through detailed analysis. High-resolution images from multiple telescopes revealed that the sunward jet was actually the result of the comet's rapid rotation, combined with the unusual size distribution of particles being expelled from the nucleus. Dr. Maria Rodriguez, who had first detected the anti-tail phenomenon at the Very Large Telescope, worked with colleagues to model how large dust particles could resist solar wind pressure, while smaller particles were pushed away normally. The combination created an optical illusion that made it appear as if material was flowing toward the sun, when actually it was the result of complex particle dynamics around a rapidly rotating nucleus. It was like solving a cosmic magic trick, Dr. Rodriguez explained. Once we understood the mechanism, the apparently impossible behavior made perfect sense within the laws of physics. The size estimates that had seemed so shocking earlier in the year also underwent revision as better data became available. The difficulty of separating light from the nucleus versus the surrounding coma had led to initial overestimates of 3IATLAS's mass. While still enormous by comet standards, the object was likely on the smaller end of the range that early observations had suggested. More detailed spectroscopic analysis revealed why 3IATLAS had seemed chemically unusual. The object showed evidence of having formed in a stellar environment quite different from our own solar system. The ratios of various elements reflected the unique conditions around its parent star, which had enriched the comet's composition with materials rarely seen in local objects. It was like analyzing a geological sample from another continent, explained Dr. Rebecca Chang, a planetary scientist at MIT who specialized in comet composition. Different, but not impossibly different. Exotic, but still completely natural. The Very Large Telescope in Chile continued its detailed observations throughout November, confirming the presence of cyanide gas and atomic nickel vapor, substances that are commonly found in comets throughout our solar system. The concentrations were within normal ranges, and the detection methods matched exactly what astronomers use to study local comets. As data accumulated from multiple sources, a comprehensive picture emerged of 3IATLAS as a genuinely remarkable but entirely natural object. It was indeed the largest and fastest interstellar visitor humanity had ever observed. Its composition did reflect the alien environment where it formed billions of years ago. Its trajectory was unusually well aligned with our solar system's architecture, but none of these characteristics required explanations beyond well-understood natural processes. 3IATLAS was exotic enough to be fascinating, but not so exotic as to require alien engineers. Dr. Avi Loeb himself acknowledged the mounting evidence with characteristic intellectual honesty. In a blog post published in mid-November, he wrote, "The accumulating data strongly suggests that 3IATLAS is behaving exactly as we would expect a natural interstellar comet to behave. While I maintain that considering artificial origins was a valuable exercise, the evidence now points overwhelmingly toward a natural explanation." But Loeb also emphasized the broader value of the episode, the fact that we took the possibility seriously, that we designed specific observations to test the hypothesis, and that we followed the evidence wherever it led. This is exactly how science should work when confronted with anomalous phenomena. The scientific community had demonstrated something important during the 3IATLAS episode. When faced with unusual observations that could potentially indicate artificial origins, Astronomers hadn't simply dismissed the possibility. They had designed rigorous tests, coordinated unprecedented observation campaigns, and followed the scientific method to its logical conclusion. Dr. Tom Statler, NASA's lead scientist for solar system small bodies, summarized the situation perfectly. 3I TLAS looks like a comet, behaves like a comet, and has the chemical composition of a comet. If it walks like a duck and quacks like a duck, it's probably a duck. But the episode had revealed something profound about how modern astronomy operates in the age of social media and global connectivity. Never before had so many people worldwide followed a scientific investigation in real time. Never before had the distinction between speculation and evidence been so publicly tested. The contrast between the careful, methodical approach of professional astronomy and the viral speculation on social media had been stark. While conspiracy theories flourished online, scientists had quietly continued their work, taking measurements, analyzing data, testing hypotheses, and following evidence toward truth. Dr. Sarah Chen, reflecting on the months since her initial discovery, noted how the episode had actually strengthened public understanding of how science works. People got to see the scientific method in action on a global scale. They watched us consider extraordinary possibilities, design tests to evaluate them, and follow the evidence to its conclusion. The international coordination that had emerged during the 3I-ATLAS observation campaign also demonstrated humanity's capacity for scientific cooperation. Space agencies that normally operated independently had seamlessly collaborated to track a single object. Telescopes on multiple continents had coordinated their observations. Data had been shared openly and analyzed collectively. As November progressed and 3I-ATLAS continued its journey back toward interstellar space, the object's behavior remained entirely consistent with natural comet activity. The brightness curve followed predicted patterns. The outgassing continued to match theoretical models. The trajectory showed no deviations from pure gravitational motion. What had seemed like anomalous behavior gradually revealed itself as the natural consequence of an unusually large, fast-moving comet from an alien star system. Every mystery found a physical explanation. Every anomaly fit within the bounds of known science. The episode demonstrated both the power and the limitations of human pattern recognition. When confronted with the unknown, our minds naturally seek explanations that fit our hopes and fears. The possibility of alien contact is so compelling that we're predisposed to see signs of intelligence even in natural phenomena. But the 3I-ATLAS episode also showed that science provides a reliable method for distinguishing between what we want to be true and what actually is true. Through careful observation, rigorous analysis, and honest evaluation of evidence, humanity had solved another cosmic mystery. As 3I-ATLAS prepared to leave our solar system forever, it carried with it the distinction of being the most thoroughly studied interstellar object in history. Every detail of its composition, behavior, and trajectory had been documented. Every anomaly had been explained. Every question had been answered. But perhaps most importantly, 3I-ATLAS had served as a dress rehearsal for humanity's eventual encounter with genuinely anomalous phenomena. We demonstrated our ability to coordinate global observations, maintain scientific rigor under public pressure, and follow evidence toward truth even when that truth might disappoint our deepest hopes. The cosmic visitor from another star system had taught us as much about ourselves as it had about the universe beyond our solar system. As we reach the end of our journey through the 3I-ATLAS saga, I want you to think about what this story really represents. Whether you see it as humanity's brush with potential alien contact, or as the most fascinating natural comet ever observed, one thing is undeniable. 3I-ATLAS changed us in ways that will resonate for generations to come. By December 2025, as 3I-ATLAS faded from view and began its long journey back to interstellar space, the cosmic visitor had left behind something more valuable than any alien technology could have been: a blueprint for how humanity will handle future encounters with the unknown. The protocols established during the 3I-ATLAS observation campaign now serve as the foundation for how we'll study every interstellar visitor that follows. The International Asteroid Warning Network, which had never dealt with anything quite like this before, developed rapid response procedures that can coordinate global observation campaigns within hours of detection. Dr. Lindley Johnson, NASA's planetary defense officer, described the new protocols as a complete transformation of how we approach potentially anomalous objects. Space agencies now maintain dedicated rapid response capabilities specifically designed for trajectory analysis of interstellar visitors. Telescopes worldwide have established priority observation schedules that can be activated when objects exhibit unusual characteristics. But perhaps most importantly, the scientific community has developed formal frameworks for distinguishing between natural and potentially artificial objects. The criteria aren't based on wishful thinking or science fiction scenarios, COS. They're rooted in physics, engineering principles, and observable characteristics that would genuinely indicate technological origin. These frameworks ask specific questions. Does the object exhibit controlled propulsion? Are there signs of structured materials or geometric patterns? Does it emit signals or respond to attempts at communication? Does its behavior suggest intentional maneuvering rather than passive gravitational motion? 3I-ATLAS had given us the perfect test case for applying these criteria, and in doing so, it had essentially created the handbook for evaluating future visitors. The technological advances that emerged from the 3I-ATLAS campaign are equally significant. The coordination between Mars orbiters, Jupiter missions, and Earth-based telescopes demonstrated capabilities that hadn't existed before. Engineers proved they could rapidly reprogram spacecraft for unexpected observations, coordinate data collection across multiple platforms, and process enormous amounts of information in real time. These capabilities will be crucial as we enter what astronomers are calling the interstellar visitor era. The Vera Rubin Observatory, that began operations in 2026, is expected to discover dozens of interstellar objects each year. Each discovery will benefit from the observation techniques, analysis methods, and coordination protocols developed during the 3I-ATLAS campaign. Dr. Sarah Chen, whose late-night discovery had started this entire adventure, now leads a new international working group dedicated to interstellar object studies. 3I-ATLAS taught us that we need to be ready for anything, she explains. The next visitor might be completely natural, or it might be something that challenges our understanding in ways we haven't imagined yet. But the legacy of 3I-ATLAS extends far beyond astronomy and space exploration. The episode became a masterclass in how information spreads in the digital age, how scientific literacy affects public discourse, and how society processes potentially transformative discoveries. The viral misinformation campaign that surrounded 3I-ATLAS revealed both vulnerabilities and strengths in how modern communities handle extraordinary claims. On one hand, false information spread with alarming speed, reaching millions of people before fact-checkers could respond. Fabricated quotes, doctored images, and conspiracy theories created an alternative narrative that competed with scientific evidence. On the other hand, the episode demonstrated the power of open science and transparent communication. The real-time sharing of observational data, the public availability of scientific papers, and the willingness of researchers to engage with public questions helped many people distinguish between evidence-based conclusions and speculative theories. Educational institutions worldwide now use the 3I-ATLAS case study to teach critical thinking, media literacy, and scientific methodology. Students analyze how the story evolved across different platforms, how to evaluate sources of information, and how to distinguish between speculation and evidence-based conclusions. Dr. Michael Chen at Stanford University, who developed one of the most widely used 3IRTLAS curricula, notes that the episode perfectly illustrates both the benefits and dangers of democratized information. Everyone had access to the same data that professional astronomers were using, but not everyone had the training to interpret that data correctly. The psychological impact of 3IATLAS shouldn't be underestimated either. For several months, millions of people worldwide lived with the genuine possibility that humanity might be encountering alien intelligence for the first time. That experience, the hope, the fear, the excitement, the anticipation, has permanently altered how we think about our place in the universe. Public opinion surveys conducted after the 3IRTLAS episode showed significant increases in support for space exploration, the search for extraterrestrial intelligence, and international scientific cooperation. The cosmic visitor had reminded people that we live in a vast, mysterious universe where extraordinary discoveries are always possible. Perhaps most remarkably, 3IATLAS had demonstrated humanity's capacity for global coordination in the face of the unknown. When confronted with something that might represent first contact with alien intelligence, our species had responded not with panic or conflict, but with curiosity, cooperation, and methodical investigation. The space agencies of different nations had worked together seamlessly. Scientists had shared data openly across institutional and international boundaries. The public had engaged with complex scientific questions on an unprecedented scale. Even the conspiracy theories and viral misinformation, while problematic, had reflected humanity's deep fascination with cosmic mysteries and our desire to find meaning in the universe. Dr. Avi Loeb, whose hypothesis had sparked the global conversation, reflected on the episode's broader significance in a speech at Harvard 6 months later. 3IATLAS taught us something crucial about how to approach the unknown. We can consider extraordinary possibilities without abandoning scientific rigor. We can maintain open minds without losing critical thinking. And we can prepare for transformative discoveries while remaining grounded in evidence. As 3IATLAS faded into the distance, carrying its secrets back to the interstellar void, it left behind a changed humanity. We'd experienced our first global dress rehearsal for potential contact with extraterrestrial intelligence, and we'd learned that we're more capable of handling such encounters than we might have expected. The episode established new standards for scientific communication, international cooperation, and public engagement with potentially transformative discoveries. It showed us both our vulnerabilities to misinformation and our capacity for rational evaluation of evidence. Most importantly, it reminded us that we live in an age where visitors from other star systems will become routine guests in our cosmic neighborhood. The next interstellar visitor might arrive next year, next decade, or next century. It might be clearly natural, obviously artificial, or something in between that challenges our understanding in ways we can't yet imagine. But thanks to 3IATLAS, we'll be ready. We'll have the observation protocols to study it properly. We'll have the international frameworks to coordinate our response. We'll have the communication strategies to engage the public responsibly. And we'll have the scientific methodology to distinguish between hope and reality, between speculation and evidence, between what we want to find and what actually exists in the vast darkness between the stars. 3IATLA had come from a stellar nursery that existed billions of years before our sun was born, carrying materials and secrets from worlds we'll never see. It had travelled through the cosmic void for eons, surviving the death of its parent star and the birth of countless others, before finally arriving in our solar system at exactly the moment when humanity was capable of recognizing what it represented. In the end, whether 3I-ATLAS was a natural marvel or a missed opportunity for first contact matters less than what it taught us about ourselves. We discovered that we're capable of coordinated global response to cosmic mysteries. We learned that science provides reliable methods for distinguishing between extraordinary claims and extraordinary evidence. And we proved that humanity is ready, perhaps more ready than we ever imagined, for whatever the universe might send our way next. The cosmic messenger from another star had delivered the most important message of all. We are not alone in our curiosity about the universe, and we are capable of exploring its mysteries together. As we continue our journey through the cosmos, carried along by our small blue planet orbiting an ordinary star in an unremarkable galaxy, we do so with the knowledge that visitors from other worlds are already among us, and that we have the wisdom, the tools, and the cooperation necessary to meet whatever comes next. The universe is vast and full of wonders we're only beginning to discover. 3I-ATLAS was just the beginning.